ternary oxyacids. So again, aqueous solution of a compound containing hydrogen, but now the other part of it is an oxyanion. So something like sulfate or hypochlorite, okay? One of those polyatomic ions that has oxygen in it. The names for these oxyacids are derived from the names for the oxyanion involved. So if the oxyanion name ends in -ate, we change the ending to -ic acid. If the name ends in -ite, we change it to -us acid. Oh, I meant to italicize acid there, I forgot. So that can be a little tricky to remember which one goes with which. So I have a silly sentence for you. Rick ate him before he could bite us. Isn't that silly? Okay, so how does that have anything to do with this? There's ick and ate go together. Ite and us. I know the O is a little bit of a stretch there. Rick ate him before he could bite us. Ick and ate are paired. Ite and us are paired. So we find the name of the oxyanion, like if it's nitrate, we change the ate to ic acid. Nitrate becomes nitric acid. If it was nitrite, it would be nitrous acid. Okay, so we've got these patterns so that we learn a pattern and then we apply it to a whole bunch of things. And this is way, way better than how naming of compounds started out, where whoever found it got to name it. And then somebody found it in a different country and gave it a different name. And we ended up with multiple names for compounds, and none of the names suggested their composition, and really, really confusing. So I understand that nomenclature can be very confusing to a beginning student, but the alternative is far worse. So we're learning patterns. When we're looking at the formulas, just with the binary acids, the number of the hydrogens in the formula equals the charge on the oxyanion. So now that we've gone over the basics, let's do some examples. Name these guys. Okay, so when we look at this, we see that it is aqueous and that it starts with H. That tells us this is an acid. Thanks for slamming the door. So what we want to do is we want to look at the rest of it. We're going to cover up the hydrogens. I'm covering up the hydrogens with my arrow. Cover up just the hydrogens. What's left is the anion, the oxyanion. So I'm going to actually write that down just to be more clear. So that's PO4. It's got a -3 charge. You don't necessarily have to have the charge for this. Just put it down there to not confuse people. What's the name of this ion? Phosphate. So this is phosphate. So we're going to take the 8 off. And which one goes with 8? Ick or us? Ick. Rick ate. 8 and ick go together. So this is going to be an ick acid. Now, if you just followed that strictly, you'd end up with phosphoric acid. Remember I said the or in phosphorus comes and goes kind of randomly? This is where it comes back. And so this becomes phosphoric acid. So the OR comes back. And that OR detail is not something I will try to trick you on either. So phosphoric acid. It does not start with hydro. Acid names that start with hydro are binary. 2 elements, hydrogen and a nonmetal. This one has 3 elements, hydrogen, a nonmetal, and oxygen. So we take the name of the anion, phosphate, we change the ending to ic acid, phosphoric acid. Any questions? So we need to know those oxyanion names, not only for naming ionic compounds, but also for naming acids. I don't just randomly assign lots of things to memorize. Okay, so this guy, HBrO2. It's an acid, and we've got 3 elements here. So let's cover up the H and identify what that is. What's the name of that ion? It's bromite. Bromate is BrO3. This is bromite. So I'm going to change the ite to us, and this is going to become bromous acid. Any questions? Once you see the pattern, it's not that bad. HClO4. Cover up the H. What's the name of the ClO4? Perchlorate. Chlorate is ClO3. This is hyper. It's got extra oxygen, extra energy. This is perchlorate. So we change the H to what? Ic. So perchloric acid. Any questions? The 2 different kinds of acids, binary and ternary? Yeah. The binary only has 2 elements, and the ternary has 3 elements. That's okay. Your brains are trying to absorb a lot of information, and it's really understandable that some of it slides out your ears. So you might want to check the back of your shirt when you get home. Write formulas for the following compounds. So when they're all mixed up together, we can see from the name that it's an acid. It's got acid in the name. But then to write the formula, we need to know what kind of an acid is. Binary acids start with hydro. These ternary oxyacids do not. None of these start with hydro. This isn't hydrochlorous acid or hydronitric acid or something. There's no hydro. So this means that we're going to take the name and we're going to go backwards with the ic-8 thing. We're going to change ic back to 8 to find out what this ion was. That looks like periodic acid, right? It's my favorite acid just because of its funny name. It looks, and it's like periodic acid. Is it only an acid sometimes? You know, maybe every Thursday it's an acid and other days it's not. What? No, it's per-iodic acid. But thankfully, you know, pronunciation doesn't come into any of our exams. Follow the pattern. Ic acid. We change ic to 8. So we just copy this down even though it looks really weird, and then we're like, oh, that's per-iodate. Well, I remember what chlorate is because Mrs. K said I had to memorize that. That's chlorate. This must be iodate. Per-iodate has an extra oxygen. So per-iodate is IO4 with a -1 charge. You see how I did that? Now I'm going to look at the charge. It's -1. That tells me I need 1 hydrogen. And so the formula will be HiO4 aqueous. Okay? Sometimes students tell me that it looks easy when I do it. I've been doing it for a really, really long time. So it is easy for me. And if it looks easy to you when I'm doing it, that's a good sign, but you still have to go home and practice. Because when you watch those professional football players throw those long passes, they make it look easy, right? Could you go out on Sunday afternoon and do that? No, you have to practice. Question?
So the hydro, you only use that when there's two elements, or there's
Mm-hmm. Two elements, hydrogen and another element. If there's an oxygen in there as well, then you don't use the hydro. So let's look at this one, chlorous acid. We change us to ite, right? So this becomes chlorite. We need the formula and the charge for chlorite ion. Well, we had written this down. That's chlorate. ClO2 minus. The light version. We look at the charge. -1. We need 1 hydrogen. So HClO2 aqueous. Formula for the acid. Nitric acid. It becomes what? Becomes nitrate. Nitrate is NO3 minus. -1 again. I probably should have done one that wasn't -1. HNO3 aqueous. Nitric acid. Let's do one that isn't. You have a question?
Yeah, you know how we did the first one? We went from 3 to 4, you added oxygen.
Mm-hmm.
For now, the chloride. The original is CO.
This is the original right here.
Okay, and for the chloride.
So this is the light version. It's got 1 less oxygen.